Hello everyone, my name is Anton, and I have a great conversation on my channel today. I talked with Anna and Alexander. Anna is co-founder and CEO of OpenCV AI. She's been working in computer vision since 2011 and has created solutions for ARM, Snap, and other companies in 60 countries. Alex is the lead engineer at OpenCV AI and maintainer of the OpenCV library. He does the day-to-day development of the library, works with code with all OpenCV community. And he is like one of the main guys in OpenCV nowadays. I will start interview from OpenCV, then we will discuss OpenCV AI projects and computer vision in general, of course. Let's go. Hi everyone.
Hi.
Yeah.
Hello.
So let's start our discussion from OpenCV. And OpenCV, it 25 years old or something around. When did you join developing of OpenCV? Because you're probably too young for start from the beginning.
Yeah, we both didn't create it. So I joined in 2011. Alex, when did you join before me?
2010 is probably.
Yeah. Why did you choose to join OpenCV? What was the initial idea to develop open source behind it?
I got lucky. That's how I joined. So I was on my second year in the university when I needed to choose my scientific advisor. And we had there was this event when all the possible scientific advisors in my university, they came and they kind of presented their, develop like the areas that they are interested in, the research, like papers that they are focused on, stuff like that. So there were 15 people. And I was sitting there with my friend who I studied with. Now, after this, 15 people were talking about like completely different research topics. I was like super overwhelmed. I didn't understand anything. So I was talking to my friend and I'm like, who should I choose? I don't know. Like, I didn't catch anything. And she's like, the computer vision guy was the best. So we should both go to him. This is how we approached Viktor Yerохimov the first time, and he was leading the development of OpenCV then. This is how I got interested in OpenCV. I got into OpenCV, and I started actually working on OpenCV as an engineer in 2011 after that, like 2 years after that. And Alex?
Yeah. So it was so many years ago, frankly speaking. So I was interning in Intel here in Belgrade locally, and the internship was aligned with my university master program. As soon as I finish my master degree, then I should leave Intel if they don't propose any alternatives. And that time they didn't have open recs for interns, and I had to find a good job. And that time I was kind of invited, recommended to ITSY's company. It was local company in Belgrade. They worked on computer vision, and it was very, very cool. It was kind of very interesting thing. And the time I joined the company just as a junior engineer, and my first topic, my first project was related to OpenCV. And till that time, I work with OpenCV. I work on OpenCV time to time with some interruptions. So my career with OpenCV started earlier with 2.4 something. So that's it.
Yeah, and how big is currently the team that's working with OpenCV? Is it like, I expect that there are a lot of folks who help in time from time, and how big is core team and the community around?
Maybe I can use the first one. So in earlier years, OpenCV, the classic tool, was a major tool of almost all computer vision engineers, and it is worked on commercial projects. And we had some relations with large companies. They want to contribute to OpenCV, and we had even commercial projects with corporations to make OpenCV better. And at the time, OpenCV was a project inside of OpenCV, and it was kind of side effect of other private commercial projects inside of the company. And that time, OpenCV was kind of a team-driven project. So most of contributions were done by core OpenCV team or people around the core OpenCV team. Today, the situation is significantly different. So the most popular thing in computer vision is deep learning, and almost everybody do computer vision with deep learning. And most of people do use things like PyTorch and use OpenCV as kind of commodity thing, something in addition to deep learning. And the library development switched from kind of team-driven development to community-driven development. So we have not more than 10 people who contribute regularly to OpenCV. I can say that it's full-time job for them. We have a couple of guys who contribute full-time or more or less full-time. All other guys, they work for different companies and they do it as a hobby. So they participate in development, try to contribute useful things that they use or they need for their job. And most of pull requests and contributions, they came from community members. And in general, it's the same. So somebody wants to do something in computer vision. He or she tried to use OpenCV. It doesn't work well, or it works well, but for example, not in this particular case he or she wants. And these guys, they just provide a patch to fix bug or extend existing functionality or get another case that may be useful. So it's current way how OpenCV is developed mostly.
Yeah, and OpenCV nowadays, it's a collection of classic algorithms as well. And how hard it's to maintain all this pile of algorithms? Do you try probably somehow to minimize this amount of algorithms? Because obviously not all of them are useful today. And what are you thinking about this question?
Most probably you will be surprised, but most of pieces that we have in OpenCV right now, they are used by people, and we get feedback and tickets about many things, even the parts that we treated as very old, ancient, useless, and so on. People still use it, and we get a lot of tickets and pull requests about modern things, about old things, and so on. And I would say that we can split this question on two sections. So we have very old classical things. Some of them are definitely out of date and shouldn't be used. And in 5.x branch, we try to move them to OpenCV contrib repository for the case if somebody really wants to use it. Then for classical stuff, we get more and more unusual requests. For example, we get requests to extend arithmetics and basic functions for multi-channel images, more than 4 channels, for example, 100 channels. If you get some scientific data, satellite data, then you can get such many channels. The same happens time to time for resolutions. For example, in early days, when you do computer vision, you usually work with VGA camera or HD camera. And if you want to do resize, remap, whatever, then HD 4 channels, it's what you need. today we get requests, for example, to do remap or warping for images from satellites like that are more than 4K. For example, it may be 16K, it may be 100K. So they are very, very huge. And it's significantly different case for OpenCV in terms of implementation, because you need 64-bit indexes. It's significant effort in terms of optimization, because for such kind of images, it makes sense to do parallel computation in other way and so on. And for modern things, we get a lot of requests here. They are related to deep learning. And people still use OpenCV as a deep learning inference engine, even if it's not the best in class.
Yeah. And speaking of this neural network inference engine, it's at the beginning I thinking it was pretty competitor probably to ONNX engine and different engines. And what is nowadays? Do you try to develop this branch? How good is different hardware support? Because I checked there was some GitHub project with like benchmark on different platforms of OpenCVs, and there was some support for some specific NPU accelerator. I don't remember exactly what it was, but at least something is supported, as I understand.
Yeah, so for DNN, we have like 2 points of growth. First of all, we are working continuously on our own engine for inference, and we see it as a cross-platform solution. So you can build it from C++ code and run it everywhere, on Android, on embedded Linux, on QNX, on Windows, whatever you have in your hands. The goal here is, first of all, to be accurate. I mean, to get correct result, even if it's not the best in terms of performance, but it's portable. And besides it, we are working on hotspots and try to optimize important things like attention, like convolutions, do some graph fusions optimizations. It's our own engine. And another branch is try to adapt existing libraries and engines that already work well. And we know that they are good enough in terms of performance. For example, NVIDIA provides a DNN library, and they provide a TensorRT framework for inference. Intel provides OpenVINA, and we have backends for such kind of libraries. And the goal here is not to build graph with our own facilities, but just delegate everything to OpenVINA, TensorRT, and other libraries and get the best performance. But you can achieve it only for this particular hardware, for Intel CPU or for my videos. And it's not a fully portable solution, because you cannot just build the OpenCV, for example, for Android with OpenVINA and my video stick on board. It's most probably it's achievable, but it's very hard to do, and we don't expect that it is a useful configuration.
And as far as I understand, main development currently it's like about OpenCV 5, and what will be like in core of OpenCV 5, and what is the main target? Because I just opened some roadmap, and there was some mentioning of some complex algorithms, and what is the idea behind it?
So what we decided to do, so for the text branch is very, very popular nowadays, and we have a commitment to support at least source compatibility, backward compatibility. It means that we cannot just pre-KPI change behavior and for the text branch, or just close for the text branch and say that today we have 5 text branch, everything is changed. So decision is the following. We do most of development of classical things and supplementary things in for the text branch, and do regular for the text to 5 text notches, something like weekly, bi-weekly And we have a lot of new development related to new features in 5.x. We changed structure of library a bit, changed API a bit for some technical depth. And the major point of growth in 5.x is DNN module. So we worked significantly Graph Engine, and we worked on a more accurate ONIX support to support more data types, more layers, more configurations. And the plan here is to develop DNN part in 5.x mostly, and don't merge 4.x to 5.x and DNN, or do it manually, request to cherry picks useful things. But most of other things, like classical computer vision, it is merged from 4.x to 5.x, and the switch should be more or less simple.
Am I correct that nowadays the main supporter of OpenCV is OpenCV AI? Is it like the most close related team to OpenCV right now?
So we have several people, 8 people as far as I remember, who can do merges, who can remove OpenCV repo from GitHub. This number of people includes me and Alex. But technically only Alex does the merges and does the releases.
Yeah.
So what happens right now? So we have, let's say, 3-4 people who we decide to be maintainers. They are kind of part-time maintainers, and they usually participate in the request in their area of interest, or if somebody is on vacation, for example, or not available. And in general, yes. So our team is in charge of releases. We do most of job related to releases, and main OpenCV Python, things for Android. And so in case of kind of issues, vacations, sick leave, whatever, OpenCV development doesn't stop. So guys from other companies, they will join the maintenance process.
And for OpenCV AI, OpenCV, of course, it's not the core of income. And are you more focused like on some custom development or on your products? And what is like the main branch of your work at OpenCV AI?
Yeah, so at OpenCV.ai we have 40 people, out of which 5 people are dedicated to OpenCV and OpenCV related projects. For example, a project with ARM, and all the rest are focused on projects where we definitely use OpenCV as a part of it, but they're not focused on OpenCV only. So we are focused on bringing state-of-the-art computer vision into real-life products. We only do neural networks, deep learning. We do some classical computer vision stuff when it comes to calibration, for example. But we very much prefer to do neural networks, deep learning-based approaches to everything that is related to detection, segmentation, re-identification, and other approaches. And we basically work with companies from Fortune 100 in startups all over the world to make these algorithms and to integrate them into products. And we build projects, we build solutions that are now used in more than 60 countries this way.
And as far as I understand, you have some like internal startups. Is it correct term here?
Yeah. So we basically have a team that works on internal projects, internal startups. One of the startups that we are now spinning off as a separate company that is called FitWise, and is about detecting human body in 3D in real time on iPhone. So that's what it focused. That's what is focused right now. We mostly apply it to sports and fitness.
Do you use like 3D camera or is it like plain 2D detection?
Yeah, it's plain 2D image or video input. And we basically detect SMPL, or simple model of a human body, from it. The caveat here is that this task turned out to be, well, as many other tasks in computer vision, it's heavily data-bound task. So we had to find our own ways to generate data for to be able to create data sets to train the algorithms. That's the way.
So it's mostly synthetic data sets, or
It's a combination. It's a combination.
okay. And how accurate it, like as far as I understand, you like measuring like volume and sizes of person as well as character registers, but speaking about like volume and sizes, how accurate this problem is nowadays. Like when I worked with a pretty similar task, probably like 7 years ago or 8 years ago, it was like a plus minus 1 or 2 centimeters, and it was like probably not enough for such tasks. And how good it's today?
So 1 or 2 centimeters actually sounds really decent. I would say if we're talking about like the waist measurement, it's really hard to do. We are not at this level of accuracy yet. We have bigger errors. So basically from a single photo, we measure the human body at like about 3 to 4 centimeter accuracy for the like waist or hips measurement. Now, I know one private technology that claims that they have 1 to 2 centimeters, like 1 centimeter accuracy, and everything that is on the state of the art, like everything open source that I saw are way worse than us. So like bigger errors when it comes to measurement from a single photo. So yeah.
Yeah, it's like it's pretty complex task, and it's interesting. But is it enough to track like some progress during the time?
Yeah, I mean, if we're talking about the body measurement, it is definitely enough for some tasks, right? So if we're talking like, it won't be able to super precisely measure the body so that you can, get a tailored suit, for example. But if we're talking about, the progress during weight loss or exercises or, any lifestyle change, it is enough to get an idea how the body is changing over time.
Yeah, it's super interesting. And am I correct that you are like a product owner role for all these tasks and all the startups? Because in your LinkedIn, I saw all announcement about all these ideas and probably all action behind it.
Yeah, I am. That's a good and bad thing, as you may guess.
Okay, and like today, of course, there are like computer vision is merging with all other like domains like LLMs, sound, sometimes like video, for example. So when you're developing your solutions, do you prefer like computer vision tasks, or is it like doesn't matter? What is your focus for such questions?
Yeah, we purely focus on computer vision. We do have some LLM experience on the team, but we prefer to be kind of this laser-focused team that has expertise in computer vision than everything altogether.
Yeah, but sometimes it's like when you have like this open world detector, when you just can detect something with one word. Of course, like accuracy is not as great as if we can like train specific model, but probably for some task it can solve such tasks. And it's like just on boundary of between one domain and the second domain, and it's always a question like if it can help to build some good solution.
I mean,
Yeah.
we definitely use, like, for example, we use Clip a lot in our projects, right? And it's a blend between text and images. In this way, of course, and we basically use whatever is available on the market to do the thing that we need to do. But we do not go for like purely language focused projects. So we do need to have at least some component of the vision. Yeah.
Yeah, it sounds reasonable. And what are the most common project nowadays? Is there such term like most common project? What is most popular nowadays among all your customers?
I mean, we are very biased because for many years, the way that we kind of sold our services was people would just come to our inbox and ask for things. And this is a very biased thing to biased way to know what happens in the world, because, only these people came and some, other people didn't. We started to do more like reaching out to companies ourselves and get a kind of bigger, more full picture of what happens outside. But I wouldn't call ourselves, I don't think that we know kind of fully what are the most, common projects out there. However, we get more and more projects that are related to 3D. It happened, it's not the first time, right? So we had 3D projects during the whole kind of company history. But I would say now it's more and more, even if they don't kind of look as 3D projects. So for example, one of the projects that we did is like we needed to very accurately understand the position of human kind of hand to be able to do some AR experiences. So AR experiences are not about it's not necessarily 3D, but to do it, we actually need to understand the full geometry of the hand in 3D. There was a certain point when people would come and ask about AR a lot, and obviously after Apple Vision Pro launch. But I would say that this kind of wave is not longer there. So we do not see these many projects related to AR today.
Probably robotics is in hype as well, because there was 10 different new robots this year, and a lot of discussion about how you can use LLM to navigate such robots
Yeah, that's true. So right now we are working on a robotic hand projects to kind of grab stuff with it. For sure, we do see robotics projects more now.
So, yeah, I also agree that probably AR, VR, and robotics is most trending nowadays. And what I don't know if you can answer such question, but what is most closer to state of art in terms of most modern neural networks, most modern computer vision project did you have? In brief details, is it was for robotic arm or?
That's a good question. So, the way that we kind of work with the state-of-the-art algorithms is that when something comes out, we test it over kind of the next week or so. We try to test something new and exciting, and we try to make it a part of our process. So, for example, with SAM, we used SAM previously for our pre-annotation for data to accelerate it. What we find is for the objects that we are interested in, SAM is out of the box SAM. We cannot apply it to kind of detect things on conveyor belt or something. There will be errors, but it's great to pre-annotate things and accelerate the project, the data annotation significantly with that. So this is what we've been doing for several years now. Now we are now switching to video SAM to do that, because in many cases we need to annotate videos, and this will be super helpful for us. So we expect to switch to video SAM very soon. That's kind of how we work. In many cases, though, we find that some new advancement in AI, they're kind of high P, I would say, right? So we find that when we really start doing, the thing that we need to do for a client, we like over something very, very flashy and new, we would choose something that is, 1 year older because it just performs better. As I said, we use Clip a lot. This is probably something that we use in more and more projects right now. We tune it into our own flavors of Clip. And it's useful in many, many tasks when we need to do retrieval from a big database. We did that in manufacturing, in retail, and now in fashion.
Yeah, I think a lot of nowadays like re-identification pipelines and some like metric learning pipelines use Clip as a base model to fine tune it. It's quite popular. And what's like from your point of view, what will be like maybe the most interesting topics today to do a new startup about computer vision? There was a lot of question about this in my channel, so I don't know if you have any ideas about this.
I mean, that's a great question. Well, I can talk a full hour about it, but there are several thoughts. First, there might be some things that do not work right now. It's not I won't give kind of any specific kind of idea, but it's a developing field, right? There are some things that do not work out of the box right now, but given the rate of acceleration in our industry, there is a chance that if you start doing something right now that is not kind of fully kind of fantastic out of the box, just wait for a couple of months and it will be there. So it's not a kind of showstopper if it doesn't. But I probably answered a different question this way. So, I mean, I'm a firm believer that you need to start a startup not because there is a cool new technology out there, but there is a customer pain that you need to solve. So that's a really big paradigm shift that every one of us, tech people needs to go through to become a product person. So I would try to just, watch out for things that you think might be improved, with computer vision, and then think how to solve it, not vice versa. Now, if there is a thing that if I still kind of had to, name one thing that I think is exciting in terms of computer vision right now, I do think that the next big thing. Right now, we kind of live in the era of AI, right? Everything is about AI. The biggest amount of money is being poured to AI, stuff like that. I do believe that the next big thing is going to be biotech. And in biotech, I mean, I have many friends in biotech community. They have a lot to solve with computer vision. Just to give you an idea, up to 30% of experiments that happen on the labs, they end in human error. And these are only the human errors that, they detected, and they did not detect something, many things. And because of that, the research is not reproducible. So there are already some startups, not a lot of them, who apply computer vision for biotech laboratories and try to kind of help, augment, solve things there. So yeah.
Okay, and if we started to talk about like next big thing and where is like computer vision is going, what do you think like will be the next breakthrough for mathematics around computer vision? Because nowadays I thinking that we at some like at some point where there was a big development, like probably a few years ago, when all this integration with LLM appears. But nowadays, all these new networks, they doesn't improve something like a lot. And even like if we're looking on some self-driving cars, it's like it's somewhere around, but it was like there was some funny interview with Musk 10 years ago when he was said that in 5 years we will have self-driving cars. And nowadays we probably at the same point. So, what do you think will be like the next big solution from computer vision? What it can solve is in future, like self-driving cars, robotics, maybe like some good augmented reality. I don't know.
I mean, on a very high level, I might not, specifically answer this first, but let me first talk about the, bigger picture. We kind of live in these cycles when there is a new technology, it performs very well. Like think, 2012, and there is ImageNet, but it's too slow to work on a consumer device, for example, phone. So there is a group of people who uses like classic computer vision up until, I don't know, 2016. And after that, we get mobile net that can actually work on a mobile phone in real time, and people start to switch to this technology. So right now, we live in era of transformers. We already have some mobile transformers, but they are not fully fledged yet. So I think that the biggest, trend that happens and will happen over the next couple of years, for sure, is that the state-of-the-art transformers, they will become locally used on mobile phones. Yeah, and after that, we will probably get one more breakthrough. So there will be a new technology that will be too slow to work on a consumer device, but it will be fantastic. So new research teams will start to optimize it. Now, yeah.
So you're thinking that all these modern foundation models will kill the current like custom neural networks that can solve some tasks. Good.
In 4 to 5 years.
Okay.
I think AlexNet timeline holds here very, very well. I think AlexNet versus MobileNet. That is what happens right now.
Okay. And how do you think it will be implemented probably on the edge, on mobiles? Will it be like some special NPUs, or do you believe more like in some GPUs? Like there are a lot of NPUs, but all of them like somehow limited nowadays.
Well, I do think NPUs, to be honest. What Apple did with Apple Silicon is truly fantastic, and it kind of jump-started a lot of progress that happens on the edge AI right now. I mean, this is kind of goes with saying that Android phones and many phones from other suppliers are also like very fast in terms of AI. But I just think that this is kind of very prominent thing that happened, right? That previously, we were not able to run like very complex AI pipelines on phones without them hitting like crazy and throttling. Right now, they still hit and they still start to throttle, but not that much. So I do think that I don't think that there will be kind of revolution in terms of how the modern phones will work. I think it will be just a gradual kind of improvement time over time, yeah.
And speaking of the phone and returning to our first part of the interview about OpenCV, like how we like as far one of my first interaction with OpenCV was in 2011 or 2012. It was on mobile, but nowadays, as far as I understand, it's not like the main target for OpenCV. Will it be changed somehow in future? And because it seemed like mobile will be one of the most important parts.
Before we go into that, do you remember if it was Android or iPhone?
It was Android.
Then you see the guy who made this code. Alex ported it to Android.
Not only. Actually, it's how to say, it's very, very tricky question. If you take a look on GitHub repository in OpenCV, there are a lot of requests to OpenCV from many, many different directions. We have very, very large surface of contact with the community. I mean, we have bindings for Java, we have bindings for Python, we have bindings for Objective-C and Swift. We have a lot of people who try to use OpenCV in many, many areas. Even, for example, we have pull request from some guy from community about QNX. They do computer vision on QNX on real-time trading system. And for now, it's very, very hard to say what is the target platform, if it's mobile, some battery powered, or it's not battery powered but connected, or it's a cloud. OpenCV is used everywhere, and it's very hard to say how to say what is the major direction. OpenCV became cross-platform, and I even saw projects with microcontrollers where OpenCV is used on a microcontroller. It's not a system with embedded system with Linux like Jefferson. It's a system when you have 1, 2, 3, maybe 4 megabytes of RAM, flash, and the bare metal software for the chip, and OpenCV or pieces of OpenCV work there well, more or less well. And for me, my understanding is that it's a mix. It's already a mix. So if you take a look on papers, even in deep learning, there are 2 strong directions. One of them is a kind of state of the art to get the best quality we can. It doesn't matter if you need 1 GPU or GPUs or even cluster of GPUs. You want to get the best result as better as possible. And another branch, significant branch, is research how to achieve decent quality, decent result with the minimum amount of compute power, battery size, and so on. And I would say it will be always, these 2 branches will be always alive, and OpenCV will be on both sides. So if you can do things locally, then you do things locally. If you don't have compute power, or you need more information like database, some other relations, then you do things in the cloud. And if you take a look on OpenCV, both directions are kind of alive. We have requests from both sides. In mobile, something that is kind of wearable like phone or some wearable device, and we have requests from guys from cloud community. For example, we have a way to transpile OpenCV to JavaScript, and we have requests time to time to fix things here and there, add APIs, make it more JavaScript friendly, and so on. It's definitely not about Android and mobile phones. It's definitely about cloud and server-side computing, and those directions are like.
Okay, it's super interesting. And what about maybe some NPU support for Androids? Or is it like, do you support it somehow now, or?
So what we have for today in terms of hardware acceleration, we have OpenCL support in computer vision and classic stuff and in DNN, and it works more or less in all areas, on desktop, on mobile phones, on Android, for example. And we have dedicated backends in DNN for particular hardware units for NPUs. So theoretically, NPU support is possible, and we have several branches where it works well directly with OpenCV, or it works with some third-party framework like OpenVINO. For example, you can use Media's devices with OpenCV through OpenVINO. So all these directions are alive. And what I would say about two different areas, so mobile phones and wearable devices, they are mostly focused on hardware acceleration, and NPU is the first class that when we need support for it. And if you speak about server side, the situation is mostly opposite. Most of people run virtual machines, Docker, OpenCV Python packages, and they don't worry about hardware acceleration for video decoding. It's pretty rare case when a customer tries to optimize video decoding and encoding. The job is usually solved another way. So you can buy just yet another server or run yet another virtual machine and worry about the hardware acceleration.
Okay. I think we're out of time. So thank you very much for the interview. It was great. Thank you.
Thank you so much. Thank you for inviting us.
Thank you.